Okay, thank you everyone. Hello and welcome to another GL Communications webinar. Good afternoon or good morning or good evening, depending on what time zone you're in. We appreciate you taking time out of your day to listen to us today. I think we have a very informative and very interesting webinar for you today. Before we dive in, just a couple administrative notes. My name is Vikram, and I am joined on this call by our Director of Engineering, Robert Bishevsky, and also our Senior Engineer, Raghavendra Rao. And also on this call is Sanjeev. Um, so without further ado, let's go ahead and get started. The title of our webinar today is Automated Voice Testing Over All Networks. And so we're going to talk a lot about voice quality testing. And so let's go ahead and begin. Okay, Rob, next slide. Okay, before we dive into the subject matter, just to give you a quick overview of GL Communications. Many of you are already familiar with us, but just in case you are not, we have been in business for over 30 years. We're headquartered in Gaithersburg, Maryland, USA. We also have a branch office in Bangalore, India. Actually, Raghavendra is joining us from India, and Rob and I are in our USA office. And we are a telecommunications consulting company. We actually have two divisions to our company, a consulting division and a products division. In our products division, which is what the focus of today's webinar will be on, we manufacture hardware and software solutions. And I'm not kidding when I say that we can test basically all telecommunications networks. Our focus is on test and measurement. So whether the telecom network is the public switch telephone network or an Ethernet IP network, a wireless or cellular network, a SONET or SDH network, we have test equipment that can test all of these different networks. And so part of our test equipment solutions, we can do analysis, we can monitor, we can record, we can visualize, we can capture the traffic as it goes across, we can store the data. We have a lot of powerful solutions, and basically we can do a lot when it comes to analyzing telecom networks. We can also simulate network traffic. So there's a lot we can do. So no matter what your telecom challenges are, please reach out to us, and I'm sure that we have a great solution for you. Okay, Rob, next slide. All right, so as all of you know, the world is rapidly changing. Due to the pandemic, the world is relying on voice and video communications more than ever before, right? So companies and government agencies and organizations are relying on teleworking and voice and video conferencing. And so with this rapidly changing climate, companies and government agencies and so on need proper testing solutions as more and more traffic is traversing these networks. So as you think about it, voice and video traffic is carried over many diverse networks, right? Whether it's the legacy public switch telephone network, whether it's Ethernet network carrying voice over IP, whether it's wireless and cellular networks, TDM networks, all these different networks are carrying more traffic than ever before. And what happens when you have this explosion in voice and video traffic is that you're getting now overloaded networks, and you can get a lot more interference, and you can get malfunctioning network equipment. With all the different conversions and gateways taking place between the legacy technologies and the current voice over IP type technologies, there's a lot of gateways and conversions involved, and a lot of times that type of gateways need to be tested, and sometimes they will malfunction. And due to all of these competing effects, basically the end user, their user experience will be impacted. right? So if you're not getting good voice quality or you're not getting good video quality, even on this webinar today, as you're listening to us, you may not, perhaps you're not getting good quality. Perhaps the resolution is not good. Hopefully that's not the case. Hopefully you can hear us clearly, but you can imagine that business operations and mission critical functions really, really rely on crystal clear voice and video quality. So now the question becomes, how do you measure voice and video quality? How do you do that in an objective way, in an automated way, and in a reproducible way, and in a systematic way? So for today's webinar, we're really going to focus on voice quality testing. And we're going to focus on our ability to automate voice quality testing. We're going to talk about how we measure voice quality and all the different methods involved. And a lot of our customers are service providers. We also have equipment manufacturers. We have a lot of defense contractors and government agencies. And a lot of times they want to troubleshoot their equipment and their networks. So what you'll find is that throughout this presentation, our solutions can help you troubleshoot your networks. It'll help you identify problems in the overall network, and then you can use our solutions to better isolate the problems. And a lot of our customers want to measure voice quality as a function of position. So whether it's like in a specific geographic region and you're driving around and you want to know what's the voice quality that you're getting as you drive around through this region, or perhaps you're in a building and perhaps the building maybe does not have good GPS signal, but nonetheless you need to know whether you have good coverage in that building. So whether it's indoors or outdoors, we'll talk about how you can measure voice quality in those different circumstances. Our solutions can be used indoors or outdoors. We've literally deployed them in tunnels, in buildings, everywhere. So we'll talk about all of that. This is just meant to kind of motivate our solutions. Rob, you can go to the next slide. Okay, I don't want to overwhelm you here with this slide. We won't spend too long on it. Basically, GL Communications has both voice testing solutions, video testing, and data testing, TCP, UDP, VoIP testing, or all different types of testing solutions. And without overwhelming you, what the point I want to get across here is that all of these solutions have a common theme. In all of our solutions, we can automate the testing. That's number one. We can remotely control the testing. That's number two. And we can send all of the results to a central system. That's the third big point I want to get across. No matter where in the world you're doing the testing, you can get that data back. You can send that data to a central database in a central system where you can conveniently log in through a web-based browser and view all the information in a convenient dashboard. So no matter what type of testing you're doing, we have all the components necessary to automate it, to remotely control it, and to conveniently view the results in this web-based system. We offer both hardware and software-based solutions. Rob will talk a lot about our hardware solutions, which can interface with a lot of different technologies, a lot of different, whether it's PSTN, whether it's cell phones, whether it's VoIP systems, radios. I mean, we have really diverse solutions here that can test all of that. And so on the following slides, we'll really dive in and talk about how we do voice quality testing. So on the next slide, Rob will take over and he'll jump into our solutions. Rob, feel free to start.
All right, thanks, Vikram. Okay, so this slide is sort of similar to the previous slide that Vikram just went through, in that it's showing what we can do, how we can test the networks. Central to this is the VQuad software and the hardware, the dual UTA hardware. So we can basically connect to really any network that you want. So that includes 2-wire analog, where we emulate a phone. 4-wire analog, we could be a headset to anything, whether it's a headset to a PC, a headset to anything that requires a TX and RX. We can connect to. We can also connect to any mobile radio. This is our push-to-talk. So we can not only connect to the radio for audio, but also perform the enable and disable of the PTT circuit. And then we can also connect to a mobile phone. And there are a couple ways we can connect to the mobile phone, either wirelessly through Bluetooth, where we can completely control the phone for placing calls and answering calls, as well as performing the audio testing. And we could also connect via a cable, a wired cable, so we become a wired headset to the phone. And again, we can still control the phone. We can't do as much as the Bluetooth can, but we can still control the phone while also sending and receiving audio. Now, the VQuad is also instrumental since it has it's fully automated using the VQuad scripting. It can also be used for video testing and data testing of the networks. So in the previous slide, there was video, data, and voice. So through the VQuad, we can not only test the voice, but also test data from the phone, directly from the phone through the network. Any Android or iOS device can be used. And we can also test video conferencing from point A to point B, and retrieve video and audio MOS, mean opinion score, and a bunch of other metrics. So again, the VQuad is the central point of all this, and then at the bottom you'll see that everything goes into this central database, but you can then access it through a browser we call a web viewer. And Raghavendra will get more into the what the web viewer does. So this is the hardware, the dual UTA hardware. And as you can see, we've got all these different interfaces like the FXO, the PTT push-to-talk, the 4-wire analog. This is also a 4-wire, but this is for a handset, the handset of a phone. So it's an RJ22 interface right down here. You'll notice that we have a side 1 and a side 2. So each dual UTA can support 2 individual devices simultaneously, and up to 6 of these dual UTAs can be connected to the same VQuad system, so 12 total devices maximum running simultaneous tests. And on the back, we have GPS. This is how we're going to basically stamp the results with lat long so we can plot it in Google Maps, for instance. Okay. Here's some other platforms that we can use with the dual UTA. So this is our portable. We call it VQuad Probe HD. So the dual UTA is on the top of this, and on the bottom is a full PC. This is an Intel motherboard that will run the system, run the VQuad software and control the dual UTA. You can connect a monitor a keyboard and a mouse, or you can just basically connect it to the network through the Ethernet port or through Wi-Fi and control it remotely. What's nice about this box, it is small, it's portable, it can sit in a vehicle or it can sit in a lab. Nobody knows what it is, so it's not going to walk away. And it just runs tests. And then if you want to control it, you can put a monitor on it, or what we like to do is just remote into it and control the unit. Another platform would be what we call our MTOP, which is a rack. So this uses the same Intel motherboard as the previous, but now it's in a 1U rack. And with this, we can put 3 dual UTAs inside the rack, okay? And the motherboard is in the back. You can actually stack these as well. So you'll see it over here where we're actually stacking it, going from this USB to that USB over here. So you can actually stack 2 of these racks. So one rack would have the single board computer, and the other rack would not. And the one computer will control all 6 dual UTAs. So 3 dual UTAs in one rack and 3 dual UTAs in the second rack. So here's how you can get a full system of 6 dual UTAs or 12 devices in 2U. Okay, so now what I want to just go over is some of the different network solutions that we can support. So, and I may mention briefly earlier, but so this is wireless networks. So again, we're connecting to a mobile phone through Bluetooth or through a wired headset, and we're controlling the phone. That means we're telling the phone to place a call or answer an incoming call. So we'll get an event that says there's an incoming call, and we can automatically answer the call. With the Bluetooth, we can also send any Bluetooth command to the phone, such as what's the signal level, and we can convert that to an RSSI, or what network are we on, things like that, and then all the voices over the Bluetooth interface, or the wireless Bluetooth. On a wired headset, we can still control the phone, so we can emulate the button on a headset. Pretty much, that's what we're doing. So with that, we can answer a call or disconnect a call, and we can also invoke Siri or Google Voice directly from this wired headset, and then using our text-to-speech function that's built into the VQuad, we can then tell, once we invoke Siri, we can say, call 555-1212, and automate the calling process. Another thing we can do is, since we are a headset to the device, we also have the ability to test over-the-top applications. So, for instance, Skype or WhatsApp or things like that, we can test the audio quality of these. Now, if, for instance, Siri can start Skype, which I know Siri can do, so we can say, Siri, make a Skype call to whoever, then we can automate the full call process of the OTT applications as well, and perform voice quality and so forth. Okay, so that's testing over a wireless network. Another thing is analog. So analog, we can test on 2-wire analog. So we emulate a phone. That means that we go off hook, we wait for a dial tone, we place a call, wait for a ring back or a busy. The other side is waiting for an incoming call, basically a ring, and we can connect the call. So it's all automated, fully automated, goes through the full call process, and there's configurations built within VQuad to specify what your dial tone is and what your ring back and busy tones are, depending on what region of the world you're in. So full, complete testing of the analog network. That's 2-wire, 4-wire analog. Again, we're just a headset, so we can, once the communication is established between the 2 points, we can send and receive audio. So all that is available. Okay, so let me now the other thing I wanted to mention here is so with the wireless network for Bluetooth, we do support narrowband audio as well as wideband audio. So narrowband for legacy networks, wideband for voice over LTE, 5G. So fully support those networks. We are network independent. We don't care what network you're on, what carrier you're on, because we're a headset to the phone. With 2-wire analog, we support narrowband and wideband. So we do support wideband 2-wire, basically HD voice, high definition voice, for some carriers that are carrying high definition to the home through an ATA or something. And then for 4-wire analog, we support narrowband, wideband, as well as super wideband audio. So we can send up to 48,000 samples per second, or basically full audio bandwidth. And that's good for connecting to headsets, even connected to a wireless phone through the wired headset connection. Now for another method of testing is our SIP testing. So we can be the VQuad software could be a SIP user agent. This doesn't require the WTA. It's basically just a license. So the VQuad becomes a SIP user agent. You fully configure how the SIP will connect to how the VQuad SIP user agent will connect to the SIP network. And we can then place SIP calls. You can specify what the codec is. Again, we support all different codecs, and there's a full list on our website. So full testing of SIP, both call control as well as voice testing. Other ways to test a VoIP SIP network would be connecting to an ATA. If there's an ATA to the home, analog telephone adapter, we can connect to the 2-wire interface and then go out SIP. Another way is through the RJ22 handset. So we can be a handset to a SIP phone, for instance, and then send and receive audio for testing the quality. Now, once the call is established, whether it's a wireless call, a 2-wire call, a handset call, whatever, once the call is established, we can send and receive audio for voice quality. We also have several other metrics we can perform, such as audio dropout analysis. For instance, if we send audio from one end to the other of the call, we can analyze to determine if all the audio that was sent was received, or if there was any dropouts and how much dropout there was. We can provide speech and noise levels, frequency analysis. This is interesting because this will let us know, for instance, on a voice over LTE call, if we're supposed to be at wideband, well, we're going to send wideband through the network. Did we receive wideband at the other end? If not, then somewhere in the network it dropped down to narrowband. So that's an important test because that will, absolutely affect the voice quality. And in this case, we can also test delay measurements, as you can see on the screen. So we can test both one-way and round-trip delay. One-way being from phone 1 to phone 2. So I'm going to send audio from phone 1, I'm going to receive it on phone 2, and I'm going to let you know the delay within a millisecond. And that can work if both devices are on the same dual UTA. So if the two phones are on the same dual UTA, that works without a problem. If they're on separate dual UTAs, within the same location, within the same lab, for instance, we can also support that using a cable to make sure that the clock from one dual UTA gets to the other dual UTA. If they're geographically separated, so they're not in the same lab, then we would use a GPS receiver at both ends to make sure that the timing is synced to GPS. So in all cases, the one-way delay measurements will be within a millisecond accuracy. Round-trip delay, what that does is, so we're going to send a signal from the phone 1 to phone 2. Phone 2 will loop it, and then phone 1 will get it back and provide a round-trip delay from phone 1 to phone 2 and back from phone 2 to phone 1. This does not require GPS. The two phones can be geographically separated. It doesn't require anything but setting the second phone into a loop back and running the test from the first phone. Okay, and then finally what I want to just talk about is the script editor. So I mentioned it briefly before, but what this does is this fully automates the VQuad, meaning that we can set up a full test routine with conditional statements. Wait for an event, wait for an incoming call, wait for energy to be detected, wait for a digit to be detected, and perform a function based on what we got. So wait for something and then use an if-then statement. Okay, if energy was detected, do this, otherwise do that. If digit 1 was detected, do this, else if digit 2 was detected, do something else. Full conditional statements, looping, do loop for 10 iterations. And then full access to every function within the VQuad. All that is available in the scripting. The scripting is pretty simple to set up. This is the script editor. It's a point and click. So on the left side, all these will expand, and there's a ton of different functions available. You click on the function, it'll bring up a screen so that you can configure what you want to do and set it into the script. You can also add comments to the scripts, and then save the file. It's just a text file, so you can actually go into Notepad and edit the script as well. This fully automates the testing, and again, this will automate the voice testing, the video testing, and the data testing, all from a single script. Now, the other thing we can do in terms of automation, the VQuad fully supports a command line interface for remote operations, as well as an API where you can basically put a library inside your own application to control the VQuad. And the CLI and the API, things you can do are load the script and run the script. Okay, so you can simply just say load a specific script and run it, or load a script with parameters and run that script. Or you can go down to place call, answer call, send file, record file, do all those things right from the CLI or API. So completely bypassing the script. You can create your own automation directly from these functions, the CLI and API functions. And this is just the script running from the VQuad, and it'll just show you what line you're on in the script, and what in the bottom left-hand side, it'll give you a status of what the devices are doing at any given time. Okay, so what I'm going to do now is we're going to be talking about the GPS. Getting location from the GPS satellites into the WTA for both lat-long location as well as for timing. And we're going to be talking about the ITS, which is the indoor tracking system that Vikram briefly discussed. This is basically the ability to plot the results when you're inside of a building or underground, anywhere where you're not going to have a line of sight to the GPS satellite. So I'm going to turn it over to Raghavendra, and he will be discussing these, plus a few other things as well.
Yeah.
Raghavendra? Okay.
So yeah, so GPS and ITS is an important part of the voice quality. If you are trying to check the quality of the network from one area to the another area, or the route. Say, for example, you want to check the quality from the airport to the malls, or a central mall or something like that. So you want to check the route. You want to check the routes, and you want to check the quality of that route, how the performance of the voice are. So in that perspective, GPS will come into the picture, where in which you will be connecting the GPS to the WTA HD hardware, which will be controlled by a software, and that device can be carried in the backpack, and you can do a walk test as well. So if you want to do a walk test, you can do a walk test as well, or you can just place that device or connect that device in a car or a train, maybe, or maybe a van, or in a public transport as well. So you can connect that devices, and you can place a route that, okay, fine, I need to go to these routes, and you need to check the quality from this route. How is the quality from these routes, or maybe the streets? So in that perspective, so before starting that travel, you can just start the test. And once you start the test, and it is completely automated, so no need of human interaction is required. So you can just travel, or you can drive, and the test will be automatically running, and it will be generating the MOS with the GPS location, GPS lat and log. So the files which were created in particular point will be having the location information as well as the MOS, so that it will be helpful for the when we plot it, it will be very helpful for the user to identify, okay, what is going on, and how is the score in this particular route. So these all results will be automatically running in the background, and you can drive, and then all these results are immediately sent to the central database. So once you see on the next slide, Rob, can you please, yeah. So on the next slide, you can see all the results which is generated while using what you can drive test. All the results will be pushed to a central database. So all the results can be plotted with, as you can see on the screen, with the informations of lat and long with the scores. So you can see, if you just point to the particular location, you can see what is the test running, when it happened, what was the test, what was the device it was running, what is the lat and long. So you can plot the route which you are traveled, and you can get the MOS score as well as the information. This is through the Google Maps, that is WebViewer Google Maps, that is our database, which will be very helpful for the customer to understand and trace like what has happened with the test, which is very important.
Yeah, let me interrupt you for a second, Raghavendra. So this is actually a test that we ran. So down here, where you'll see the little 370. This is right around where our office is, and we drove this route in our area. I drove this a few years ago, and as we drove, we had the VQuad system, the VQuad probe, in our car, and we didn't have to touch it. We started it remotely, and it just was running. And I think the probe was connected to our phone for internet, so it was sending the results directly to the central database as we were driving. Now, if we didn't have that connection, that's fine too, because the results would be just saved to the probe, and then when we got back to the office, it would stream over to the central device. So you don't have to have internet connection as you're driving, but we happen to have it, and we drove and we got these results. Now, one of the important things when you're doing this type of test, and Raghuvansh will also mention this with the ITS for the next slide, is consistent speed. So you want to have consistent speed. You don't want to be passing cars, or you don't want to be now. Obviously, if traffic slows down, you'll see more results. But you want to have somewhat consistent plotting of the results as you're driving, okay? Or if you're in a train, or if you're walking, you want to walk a steady pace. So I just wanted to let you know this was one of our test results, okay? Go ahead, Raghuvansh, sorry.
Yeah. So on the next slide. Yeah. So next is about the ITS, that is the indoor tracking system. So ITS is the automated process with manual user interaction. So basically, like we can use the ITS scenarios where the user is underground, or maybe in inaccessible places, or in a multi-floor building, like you have multiple floor. So you know the quality of the voice in each floor, or the staircases. How is the quality in the staircases, or in the like parking areas, or on those locations where it is not possible to use the GPS receiver to get the information about the location. So in that cases, we can use the ITS. So basically, in the ITS, what we do is we can define the test route manually. So we need to define, okay, when this will be completely a walk test, and one guy is required to work on that. Whereas like we need to upload, basically we will be uploading a route map. Say for example, on this scenario where we are having one route of the subway, where in which it can be a route map, or it may be a floor map, or it may be a underground subway maps also in this scenario, where we will be providing a JPG file in the VQuad, where we will be defining, okay, fine, this is the route we will be carrying on. Like you can see 1, 2, 3, 4, 5, 6, 7. So this is what we have planned. Like let's have the voice quality of this particular route. So what we will do, we will first define the routes, and then once we start the test, so test will be automatically running in the background. So we need to just walk in a same manner, like in the same pace. So we will be walking, and once you reach the next location, we need to press next. That is the only thing which we need to do. So while we are walking, so the test will be automatically running in the background, and we will be getting the mouse score. So in the same pace, you will be walking from 1 to 2. Once you reach 2, you will press next. Then from 2, you will be going for 3. So you will press next from 3. That means you are walking from 3 to 4. So in that perspective, you can track the, you can know the voice quality of that particular route, which you are, in which route you have planned.
So let me interject real quick. So again, it's a very simple process. This is a very simple thing. Basically, what you have is you have a picture of your floor, a picture of the tunnel. Somehow you have a picture. It could be, whatever picture you want. It could be a hand drawing. We don't really care. It's just a JPEG. And through our software, you can then put these little points on. This is your walking route. Okay, you're going to put these little points on. Now, you're going to put the points on where there's a definitive, something definitive within your walking route. So maybe there's a post there. Maybe it's a hallway. Maybe it's a door. maybe it's the next station of a subway system, whatever it is. That's what you're putting these little points so you have reference. Okay, so now what you're going to do, as Raghavendra mentioned, you're going to walk from 1 to 2. That's what you're going to do, and everything's running automatically. The VQuad is running automatically. You don't have to touch it. Everything's running automatically. When you get to point 2, you're going to hit this next point. Okay, that means you're going to be going from 2 to 3. Okay, so you walked 1 to 2. Now next point. Now you're going to go from 2 to 3. So now the software knows. Okay, all the first sets of measurements are going to be plotted between 1 and 2. All the second set of measurements are going to be plotted between 2 and 3, and so forth until you finish the test. So the only thing you have to do is hit next point whenever you come to the next location on the map. Everything else runs fully automatic. Okay, and then Raghavendra, go over what you actually. So this is actually showing the actual map with you running, clicking next point, and here's the VQuad running in the background, running the test, transmitting a file, recording a file, and it's actually stamping that file with information that says it's between, well, right now you're on 0.5, so it's between points 5 and 6 right now. So that it knows that that's where it's going to plot, between 5 and 6. When you get to 6, then something else will be stamped on the files, and it'll be plotted between 6 and 7. Okay, so Raghavendra, just go over this, the results that you'll get.
Yes. So this is the result which we'll be getting at the end of the test. We'll be creating at the end we'll be having a JPG file where we'll be plotting the last results. So like in the scenario where we are walked from 1 to 2, 2 to 3. So we will be plotting the results with the pass factor and the fail factor, or we can have the results in good, excellent in that format. So we can have that good results in the maybe in yellowish format, or fair results in a yellowish format, or we can have an excellent result in a green, or poor results in a red. So we can have a multiple scenarios, like we can have when the color combinations we can add from point to point. So at the end of the results, we can it will be automatically plotted, or it is equidistantly plotted between the points, and we can see the results in this format. So in this scenario, we have walked from 1 to 2. So in that, at the end, we have reached 13. So 13 is the last point. So we can see the results in this format. And also we are planning to, like, we have working on adding some pause and pause countdown also, where in which we in between, if you want to have a pause and if you want to go to a certain location where in which we cannot walk, you want to go to certain room and there is no walking space. So what we do is we just put a pause there, and you can go inside the room. You can just countdown starts. You can we'll analyze the MOS score, and we'll put an average over there, and you can come back to the original location and you can start from there. So that is the one more thing we are adding here, so that you can in those scenarios where in which you cannot walk and you want to get the MOS score of that particular small room or any certain areas which there is no much space to walk. So we are also having that scenarios where we have a pause and pause countdown options also.
Okay. So what we're basically saying there is, let's say before, when we're at point 8 and before we go to point 9, we wanted to go into this room. We don't want to measure going from point 8 to the room, because maybe we had to go in a certain manner outside through an alley or what have you, and we don't really care about those measurements. So we can actually pause the test automatically through the GUI. The user doesn't have to click pause. He just hits next, and it goes into a pause mode. It's how you configured it. You go into the room. It doesn't matter how long it takes you to get to the room. Once you get to the room, you can start running tests inside the room, and then hit next. It'll go back into pause, and you can walk over and restart your walking test inside the main room. So there's a lot of flexibility to running these tests and plotting these tests and getting exactly what would be needed. So, okay, Raghavendra, why don't we talk about the voice quality POLQA? Go ahead.
Yeah. So yeah. So what? Yeah. So for the voice quality, like we call it as a VQT. So VQT is a software which can be installed in a server, in a server or a local PC. It can be installed on that. It's just an application we need to install. So it can be installed on a cloud as well. So like you need to, like, there are it analyzes the basically what it analyzes is, we will be it may be a lot of interfaces, maybe a Bluetooth interface, maybe of 2G, 3G, 4G, 5G, or maybe a PTT, or maybe a VoIP, or maybe a two-wire line. So we say on the screen, you can see the VQuad, which has a interfaces, any interfaces you can connect. So you can have a call from mobile phone, which is a 4G, to the PSTN line on the other end. So you can have a multiple scenarios, or it is, and you can run multiple. So you can, if you have connected 12 devices, you can run those 12 devices at a time, and it will function it independently. So once you place a call, you can send the file, the other end will record the file, and the recorded file can be sent to the VQT application, and it compares it with the original file, and it gives you the MOS score. So in this scenario, what we are trying to do is, it is completely automated. So no need of doing anything, like manually doing anything. It's actually like on the script, we can just place a call, then you can send a file for the far end, or you can receive the file if you want to do it two ways. So then those files will be pushed to the VQT application, where in which it gives you the MOS score.
Okay, so let me just go over this real quick. Thank you, Raghavendra. So there's different ways. I think I already mentioned all this. Different ways to run the voice quality. Basically, again, it's sending a reference and recording a degraded, and then analyzing through the POLQA algorithm, which is ITU 863, and getting a mean opinion score, a MOS. So we can do it through the mobile phone Bluetooth testing, or mobile phone wired headset testing, and perform the automated voice quality. We can do it through analog, 2-wire analog, or 4-wire analog. Again, creating the voice quality MOS. So all we can also do it through SIP, through 4-wire analog. All of that anytime you can send and record audio through the established call, we can take that audio, analyze it, and create a MOS, a POLQA MOS. And the voice quality software supports narrowband, wideband, as well as super wideband. This is the actual software that runs. It runs fully automated. You can run it manually or automated. You can also connect to it through the CLI or API for remote testing, and generate the scores in that way. Now, the POLQA supports narrowband, wideband, and super wideband audio. So narrowband, wideband, and super wideband. This is the full band. That's the full band of an audio spectrum. And the reason I mention that is because we now support POLQA version 3, which is the latest POLQA version, and this supports full bandwidth. Okay, so up to 24 kilohertz. So this fully supports full bandwidth. The POLQA version 3 has several updates for more accuracy with some of the codecs, and just better management of the results with certain codecs. Narrowband is pretty much the same. In fact, narrowband POLQA very much resembles narrowband PESC, which was the previous algorithm, ITU 862. But POLQA really went forward with the wideband and super wideband, and in this case, full bandwidth. Okay. And it also supports OTT. So if you're doing OTT over-the-top apps, and the codecs that the OTT apps use, The POLQA version 3 is supposed to be a better for analyzing that audio. Yeah, so we do support this. We support the older POLQA. We support the POLQA version 3. We also support PESC. So any of the algorithms that you want, we can support, and it actually all gets packaged into the same VQT software. Okay, this is just showing how we automate the POLQA or the voice quality software, and we point to a directory. When files appear in the directory, we grab them, analyze them, and then generate the results. Okay, so web viewer is the final piece of the puzzle. So it's basically it is taking the results, putting them. So the VQuad and the VQT software puts all the results, all the events into a central database. You can have multiple VQuads. In fact, you can have 100 different VQuads running at different locations, all pointing to the same central location, and all putting results, events, everything into that same database. Then we use the web viewer to actually access the database and generate reports. Okay, so we can query the database, we can filter the database, and then we can take a look at the results from the database and manipulate the results in a variety of different ways. So, for instance, here we can see voice quality statistics along with a pie chart for a certain period of running the test. So, again, filtering. We can filter on a specific test or a specific time frame or a specific location and take a look at these results. So there's a lot of different parameters within the recorded files that we can then filter on and really narrow down what we want to see. Okay, and then the network status within the web viewer, this allows us to see everything in the network, all the VQuads that are connected to the central system. And then not only can we see them and see what the individual VQuads are doing, we can also remotely control them directly from the web browser. So that means loading a script and starting a script or stopping a script, things like that, specifying parameters for the script, all that can be done right from the web browser or the web viewer, okay, for any of the VQuad nodes that are connected. And then the results can be output. So this is just a screen that shows all the results in one screen, one large screen. But there's a lot of different ways that we can output the results to screen, including custom reports that allows us to customize what we want to see on the screen, what we want to see in the report, how we want to see it, including bar graphs and line graphs, as you can see here. And this allows us to specify exactly what we want on the screen, and then we can output this. We can output it to output any of the reports associated with WebViewer to PDF, Excel, or CSV. We can also schedule the reports so that a PDF or an Excel will automatically be generated and then emailed to a specific email location. And the scheduling can be done every morning, once a week, at the end of a test, or whatever you want to do, whatever frequency you want. You can specify how you want to schedule the reports to be sent to the different email addresses. Okay. Well, I really thank everybody for joining. And if you have any other questions or comments or want to discuss your testing, whether it's voice, video, data, and you know, again, the different ways that we can track the results, whether it's GPS or this ITS, just let us know. We'll be glad to discuss with you your requirements, and I'm sure we can provide a suitable solution. All right, so thank you very much.
Thank you, Vikram. Thank you, Rob. And thank you, Raghavendra.